would like you just to write next to this triangle here to prove that triangle ABC and triangle DEF are similar. And I'm just going to show you again because there's a very specific way that you have to write this down. We call it the 5-line proof. Okay, so the first line of your 5-line proof is always going to say in triangle this and this. All right, so you're basically listing the names of the two triangles. So you're just going to say in triangle ABC and triangle DEF. Then you're going to look at your two triangles and you are going to ask yourself, do I have information about the angles or do I have information about the sides? All right. You have to have information about 2 of the 3 angles. I'll explain now why it's 2 of the 3. Or you have to have the lengths of all 6 sides, right? So in this case, hopefully you can see they haven't given us any lengths. So we're going to work with the angles. So what you're then going to do is, I always number my 3 parts. You don't have to, but I just think it's nice because sometimes you have to do like working within one pair of angles. We'll get to that later. But I think it's nice for the marker if you number 1 and 2 and 3. And then you have your final line. All right, so for step 1, can we see that they have told us here that angle A is equal to angle D? They've put a dot in both of those angles. So that is going to be your first thing that you're going to write down. Your first pair of angles that are equal that you're going to list. And then, guys, you have to write given. Okay, this is the only place really where you have to write given as a reason. In any other section of geometry, if something is given, you can just use it. Okay, but for this, it's very important. You have to write given, please. Then can we also see that angle B is equal to angle E? Because they've given us a star in both of those angles. So the second pair of angles that are equal, we're going to say angle B is equal to angle E. That was also given. And then for the third pair of angles, guys, you can see I've already written in blue here. They actually didn't at first give us any information about C and F. They were left blank, all right? But because we know how angles of a triangle work, do we remember that the 3 angles of a triangle always add up to 180? So if we have 2 of the 3 angles, we can always calculate the third one, so angle C in that case, by saying 180 minus the angle A, which is a dot in this case, and then minus angle B, which is a star. Right? Now, guys, because this is a dot and that is a star, and in the bottom triangle we also have a dot and a star, does it make sense that when you subtract the same angles from 180, you're going to get the same answer? So say star was 40 and B was 60, right? The dot was 40 and the star was 60. You're going to say 180 minus 40 minus 60. For the bottom triangle, 180 minus 40 minus 60. All right? That is how it always works with triangles, guys. If 2 of the 3 angles are equal, the third angles will automatically be equal because you will calculate them in the same way. So for the third one, we're going to say angle C is equal to angle F. But now here we can't say given because nothing was given there, right? We filled in the extra blue information. We're going to say angle sum in triangle. All right, we've already done 4 of our 5 lines. Okay, the 5th line is now actually writing what we call the similarity statement, where you actually say, okay, because we have these 3 pairs of angles that are equal, we can say that these 2 triangles are similar. So you're going to say triangle ABC is similar to, so it's 3 vertical lines like that. Triangle, and now we need to match them up. So in this case, it was easy to do the matching up. We're going to practice questions where it's not so easy. But guys, if you wrote A first, in your second triangle's name, you need to write the angle that is equal to A first as well. So A was equal to D, so because you wrote A first, you have to write D first as well. So the two dot angles, basically. You can't just write the letters in any order that you want. Okay, you have to match them up. That's very important. Now B we wrote second. Which angle is equal to B? E. So I have to write E second as well. And then the last angle was C. Which angle is equal to C? F. Your reason is going to be either angle, angle, angle. Or if you want to, which I'm sure you won't, but I just want you to see it, you can also write equiangular. All right, that's not too bad. Yes?
Can we say equiangular for all like similarity stuff?
If you're doing the three angles, yes. Yeah, you can. Okay, let me just quickly.
Is there any reason why we should use one over the other?
No, no, you can decide. All right. Now, I just want to make a little note here that I know I've said it, but we haven't written it down. Here, the order is very important, guys. You'll see why that is now. So, order NB. Now, guys, that was one way of proving similarity, right? The other way of proving similarity, which we'll practice at a later stage, is showing that all three pairs of sides are in proportion. So if you take one side over the other side, simplifies to a value. Another side over another side simplifies to the same value. We will get to that. But what we're going to use similarity for the most in grade 12 is we're going to prove that two triangles are similar using this method, using angle, angle, angle. And then we're going to use our similarity statement to set up fractions. So proportions of sides. So we're going to say one side over another side equal to one side over another side equal to one side over another side. You did this in grade 9. All right. So I'm just going to add here, if two triangles are similar, their sides are in proportion. So what we're going to do is we're going to take our similarity statement, and this is why it's so important that our letters are in the correct order. So we're going to use that statement, and then we are going to use that statement to set up our fractions, our proportions of sides. Now guys, in grade 9, I always say that we draw frog faces to get our fractions. You'll see now why I say that. We're going to do a little kind of arc there over AB and then an arc over DE. So the first two letters in the first triangle over the first two letters in the other triangle. So we're going to say AB over DE is equal to. Now we're going to take the second and third letters in both triangles like that. BC over EF. And that will then also be equal to, if I take the first and third letters in both triangles. So AC over DF. Do we see the frog faces there? Okay, so those are going to be your fractions that you can then work with. So you'll see now when we do, well, we'll do it tomorrow. They often ask you to find the length of a side, but you must then say, these two triangles are similar, do your proof, and then set up your fractions, and then use the fractions to find the length of the side. Now guys, for this, you have to write a reason, similar triangles. Okay, but this is going to be kind of the most important part, or the most commonly used part of similarity. We're going to prove similarity, then use the statement, or the correct order of the letters, to set up our fractions. Okay, and then go from there. All right. No homework today, guys. We will do some examples on this tomorrow. What you can do is you can do some Siavula. Remember, the competition runs every week. On anything. Your test, the 21st of August, that's in what, like 2 weeks? 2 weeks from today, hey? Yes, 2 weeks from today. So you can practice some of that stuff there.